Let's talk about database tables. When you are doing any kind of processing, chances are you will have some relational database that you want to store the data in, or you want to query the database. So we'll talk about the relational databases today. And in case you're wondering, what if your application uses a Mongo database? Well, there is a Mongo support in ZOAPIIO as well. And it works very similar to relational databases because the way ZOAPIIO abstracts it, you're given high level commands like we've seen before in the code builder, and you can perform operations on the underlying database or underlying anything, whatever that entity is an abstraction of. So, for the sake of completeness, yes, there is a MongoDB support. You can use this, but today's session is on the relational databases. So now here I'm inside the code builder, and I would be putting this in a routine or a service or any place code builder is used. So what we do is the easiest way is that you just take the table and you drag and drop it into the code builder, and you will get some options. And I'll walk you through these options. Depending upon what kind of access you want to have to the database. For example, if you're doing a query, which means you are iterating over all the nodes, or sorry, all the rows in the table or some of the rows in the table. So there are two ways. I'll show you both. Third is if you know the key and you want to fetch it by the key, then you can use this option. Or if you are either inserting or updating a record, you can use save. And this is really nothing. It just creates a node for that, right? So what we do is we go back to this table, and for example, we go back here and check the key field in ID, which means we are saying that our table has a key. Okay. Now, if I drag and drop, and let's say I want to fetch by key, so I get a little small code snippet which tells me how to fetch by the key. Notice that there are two database statements in this. And for any database operation, you will be using one of the database commands, which is, you can drag and drop it from here. And these are the operations. There is fetch, open, next, close, save, insert, delete, or clear. Okay. Now, statements like next is used when you're iterating over a record set. Similarly, open and close are before you enter the loop and after you finish the loop. But some of these are automatically handled by some of the loop structures. So I'm going to show you where it's required and where it's not required. Okay. Next is typically never required because any loop that works on the database, it automatically advances to the next row in every iteration. So let me just throw this away. So if I want to do a fetch by key, I need to assign a value to the key. So for example, I can assign a value here. Then I perform a fetch operation on the table. And then only one row will be fetched. And therefore, there is a with, which means after fetching, all the columns are available here. Okay. And it's just a incomplete compute created here just so that you know what you want to do with it. You can just delete and do something entirely whatever you want. So for example, I can say /response /member /ID equals something like this. I think this one is with the lowercase ID. So now this is a small snippet. What it does, it reads the table with a key and copies the ID to somewhere, wherever we want to copy it, and then we close the table. Generally, closing the table is only required if you want to open the table again in the same service. If you don't close it, it's fine. When the service ends, all the open tables are automatically closed. Okay, so this is one example. Now let's take a look at another way. The simplest and the most powerful one is a simple query. It doesn't require you to open, it doesn't require you to do the close, and it's just a simple loop. You just say iterate over a table. You can optionally select a loop variable, and you can give a where clause. So I can say, for example, where ID is greater than 1000. This what they do is it will open this table with this condition and iterate over all the rows. And then I can again do whatever I want. So this is I mean, I would say a very most frequently used variant of accessing a table. It doesn't require you to do any database operation as such. It's implied because the node they are referencing is a database node. Now, sometimes what happens is that this where condition you're using is not as straightforward as a simple thing as this. Sometimes you may want to dynamically construct where condition. In that case, we will use a different variant, which is dynamic where. Now here, what we do is, with every table, there is a pseudo node called underscore where. And I can attach an SQL expression here. So I can say, for example, ID is equal to whatever I can say, for example, 100 plus value. So what I'm doing is actually I'm doing a string computation here. I'm creating a string which must evaluate to a valid SQL where condition. So I can use things like here. I can say where, for example, and if you are using strings, you have to make sure you use a single quote because SQL recognizes single quote as a string terminator. Now here I'm constructing my where, which is the selection to be used when doing when creating the select clause on the table dynamically. So you create it, put it, assign it to a pseudo node called underscore where. Then you do an explicit open of the table. And then you run the loop like you did before, except there will be no where condition because we've already provided the where outside. And after the loop, I will do a database close. So these are the various ways where I can do read operations on the table. Now, if I want to do, let's say I want to save something. So again, I can do this and then I do a save. So for saving, what I need to do is I need to assign a value to each of the columns or each of the fields or each of the nodes inside the table definition. And say ID is equal to okay. We need to use a width block here. Now I have assigned a value to each of the columns, and then I do a save. So the way the save works is, if ID is the key, it will look if this key already exists. And if it does, it will simply override the same record. But if it doesn't exist, it will create a new one. And if you want to force an explicit insert, you can say insert. What this will do is, irrespective of whether this ID exists or not, it's going to create a new one. And remember, if you do this, an ID is declared to be a unique key in your table, then this will fail, because it will try to create a new one, and it might trigger a duplicate key exception in the back. So this is how you perform read and write operations on the table. You could be getting these values from the input request, or you could be getting them from another API or from another database table. Rest is programming that I assume you know your logic. I'm only showing you how to do the interaction with the database. The values, of course, you will know where to bring it from. So this is all about interacting with relational databases, relational database tables. There is still one more thing that I need to cover, which is database queries. So as far as database table level access is concerned, this is all that you need to know. And in another session, we will talk about how to do database queries and database update queries. So thank you.